Bless the leg and greetings to all my dear students. Well, today I'll be continuing the chapter of data handling which I started in the last week. Before I proceed any further, I would like to quickly recall the content of the last week's video lesson. I remember explaining you the data types and its related terminologies, the topics in a little detailed manner. In the first chapter of Python fundamentals, we did cover the data types, but primarily based on literal. But in the chapter of data handling, we have learned quite a bit about how and why the data types like the integer, the float, the string, the tuple, the list, the dictionary, are implemented. Okay, so today I would like to focus more on the operators. Okay, so we are done with the data types, the built-in or the core data types. The explanation should be enough as of now, and then in times to come, as per the need, we'll be learning even in a detailed format. But as of now, whatever you have learned with regard to the data types should be more than enough. So today, I'll be focusing primarily on the operators. Again, we did touch upon the operators like arithmetic operators, the relational operators. So again, I'll be dealing with the complicated or the depth part of the operators. Okay, so to start with, I'll be showing you the live working of the operators, and then I'll be listing down the topics or the subtopics below, so that at the end of the class you'll be able to keep track of the stuff that we have learned in today's video lesson, right? So first things first, we did differentiate between the floating point number and the integer. The advantages of floating point numbers over the integer is it could represent numbers in between the integers. That's understandable. And then the range of floating point numbers are far greater than the integer range. Okay, so if a number could not be represented in the form of integer because of the supported range, it could still be represented in the floating point number or the numeric. So that's the range. That's something we have learned already in the last big video lesson. So, but there is one big disadvantage. The one which we have learned already is the floating point numbers are slower in operation because of the numbers that comes after the decimal point. Whereas the operation with integers is simple and straightforward, hence it's much faster. But with floating point numbers, since it has to take into account not just the numbers in front of the decimal, but also after the decimal point, hence this makes the floating point number operation much slower. And then another big disadvantage of floating point number is whenever you try to compare, you need to be very careful. For example, if I compare 0.3, okay, is equal to, I hope you're able to see, okay, 0.3 equal 0.3, I get the answer as true. Okay, however, at times you could come up with a situation like 1 divided by 3. Okay, 1 divided by 3, normally we would say like 0.3. But is this 0.3 the correct or the most accurate answer? The answer is no. It would just go on 0.333 infinitely. So the Python interpreter will come up with some approximates in terms of binary number. It has to come up with the ultimate approximate or the estimate. The problem is the numbers could just go on and on, right? So when you try to compare between the 0.3 and 1.3, at the outset, it looks the same. the answer, at the outset, should same. But when you try to compare between the two, the answer will evaluate to false. So you need to be very careful when it comes to comparing, the floating point numbers. That's, one big disadvantage. For example, let's say I come up with the example 0.1 and 0.1, and then I add 3 0.1, right? So I try to compare this with 0.3, right? So I'm just using the equality relational operator. So again, at the outset, 0.1, 0.1, 0.1, it should be 0.3. So the result of this relational expression should be true. But, okay, I made a mistake, sorry. Say 0.1. It's happening, okay. Say 0.1 plus 0.1 plus, and then 0.1 is equal to 0.3. Okay, so I've left a space here, hence the error. So at the outset, the answer should be true, but strangely, I get the answer as false. So this is again just one example why comparing floating point numbers, is a dangerous practice. Okay, so when you add these three numbers, the result, even though it should be 0.3, but internally the Python interprets the number to a better approximates. Okay, so if you just try to check 0.1 plus 0.1 plus 0.1, let's check the answer. Look at this. I get some strange decimal numbers, right? So the Python is trying its level best to come up with the best possible approximate values of numbers like 1 divided by 3 or adding 0.13 times. So the idea is comparing floating point numbers should be avoided as much as possible. Okay, so that's again one of the disadvantages of floating point number over the integer, right? So let's move on to the next topic. I did touch upon the difference between the is operator and is equal to operator. So you have this operator which are actually called as identity operators. You have two kinds. The first one is and then the second one is not. You need to leave a gap between the two. So these kinds of operators are actually called as identity operators, right? So the is operator compares the address of memory location. All right. So this is simple and straightforward. Let's say I have A equals 10 and then B equals 10. All right. So when I say A is B, I'll get the answer as true. So wherever this integer is stored, A and B are made to point to the same value of 10. So wherever 10 is located, the address will be referred to by these two variables of A and B. So when you check A is B, the answer evaluates to true. But A is equal to B. Again, you will get the answer as true, alright? Because it compares the value of A and B. So if A is B, A should always be equal to B. So this is one important thing to be noted. If A is B, A will always be equal to B. So that's understandable, right? If A and B points to the same value in the same memory location, when you compare the value between the two, the result will always be true. However, if A is equal to B, it's not necessary that A is B. So the vice versa, if you come from this to this, it need not be true always. The values could be similar, but they may not be pointing to the same memory location, or in other words, they may not share the same memory address. So I could I want to come up with 3 possible cases, right? So let's say A at input, all right? And then I would like to receive a string. So this is the first case in which even if the value of A is equal to B, but A is not B, I'm coming out with 3 possible cases. The first one is when you're trying to compare strings. So when you receive the string from the input function, the Python interpreter will create a different object. I'll get to it. Say, I have this, A is equal to input, and then let's say I have something like this. All right, so I press enter, all right, and then I write Tibet. Okay, I press enter. So the value of A is Tibet. Now let's say I have same string being assigned to B. All right, I press enter. Now the value of A is Tibet, the value of B is Tibet. Now when I check A is equal to B, I get the answer as true. However, when I say A is B, I should get the answer as false. So do you see the difference between the first and the second example? So what happens with input function is the input function will always create a different object or a different location in which the Tibet will be stored. So you have A pointing to this Tibet. And then when you assign Tibet to B, B will point to another Tibet, a Tibet which is stored in another location. So the first point should be crystal clear. With input function, a new object or new memory location will be created to hold the values. Hence, if I run A is equal to B, I get the answer as true, but when I say A is B, I get the answer as false. So that's the first case. Okay, so in short, input function will create a different object. So now the next case should be when the integers, are pretty large. When the integer value that is being assigned to a variable, if it's too large, again the Python interpreter creates a new object, right? So let's say I have A is equal to 1, 2, 3, all right? And then let's say B is equal to 1, 2, 3. Let's just check. A should be equal to B. I will get the answer as true. A is B. Again, I get the answer as true. So 1, 2, 3 is not that a big integer, right? Now let's say A is equal to 1, 2, 3, 4, right? And then B is equal to 1, 2, 3, 4. And then we'll check. I'm not very sure about the exact point at which the difference gets highlighted. So let's just check. So let's say A is equal to B. I'll get the answer as, A is equal to, do not leave a gap here. So when I press enter, I get true. When I say A is B, that's when I get the answer as false. Okay, so the integer, when they are large or pretty big in value, that's when the Python interpreter starts to create a different object, right? So I won't tell you the reason as of now. It'll be confusing. Okay, so let's move on. Now the third case. Now whenever you try to assign the floating point number or the complex number. Remember, the complex number is in the format of A plus BJ. Why is it not A plus BI as in the mathematics is? In the mathematical field or in the scientific field, the I stands for the current, right? But in programming language, you don't have much to do with the current. So in order to provide this difference or to highlight this difference, we have this J instead of I, right? So let's say, again, I have X is equal to, and then let's come up with the example of complex number, right? 1 plus 2J, right? and then y is equal to, say, 1 plus 2j. Alright, so this is a complex number. So let's try to, okay, x is equal to y should give you the answer as true, but is x is y? Okay, that's when you get the answer as false. So likewise, when you say x is equal to 0.2 and then y is equal to 0.2, let's check, whether, okay, I get to see the answer as false, right? So the three important cases are, the first one is with the built-in function of input, it creates a different object. Even though it has two similar values, but input function will always create a different object. That's number one, case number one. Case number two is if the integer are big in number, big in value. Now, even though 1, 2, 3, 4 is not really big, but that's how the Python is so designed. So that's the number two. Case number two is when the integer values are big, the Python interpreter will create a different object, even though they store the same values. And then comparing, when you assign two similar values of floating point number or complex number to the variables, even though they share the same value, but when you actually compare their addresses using is identity operator, the answer will be false. So this is something which you need to take note of. And then I left out, one important concept. Let's say 1 plus 3j. All right. So this is a complex number, right? So when you just check the type of A, I'll get this data type, right? So you have a constant representation of the complex number. Those two are real and image. If I'm not wrong, if I have something like this, a dot real, okay, I get to 1. Complex number will always have the two parts, the real part and the imaginary part. Complex number is divided into two important parts. You will learn this in class 11 mathematics, right? They are normally used to come up with estimates or projection values. Perhaps one good example could be the weather forecast. When the projection goes beyond the predefined or the known result, that's when we take the help of the complex number, right? So it's broken into two parts, the real part and then you have the imaginary. The value of j will always be square root of -1. You don't have any values for square root of -1. Square root of -4 is 2. 2 into 2 is 4. But square root of -1, you don't have any answer, right? So this is how we could actually come up with imaginary numbers. So you have basically two parts. The first one is the real part. The second one is imaginary part. 1 and 3, or A and B, are the real numbers, and J is square root of -1. So if you want to print the real part, you have this real. You could actually refer to it as constant, A dot real, and then if you want to print the imaginary part, you will get the 3. Okay, so the fact that I get this 1.0, 3.0, it means 1 and 3, or they'll be represented generally as A and B. A and B are real numbers or floating point numbers. Because when I run this, I get 1.0, not just 1. Likewise 3.0, not 3, right? So this is basically the difference between the is operator and equal to operator. Okay, now let's move on to the next topic. Now let's come up with the logical operators. Now this is super important. Logical operators. Logical operators could be three important operators. The first one is you have just note it down. Logical operators. You have not, or I'll start with or, and then you have not. All right. Or means if one of the two conditions is true, the overall result will be true. So these are logical. Logical means something which is based on reasoning. Or the best example could be, let's say I want to see Tenzin or Tsering. Let's say I want to see, I'm saying this, I want to see Tenzin or Tsering. Okay, so if Tenzin turns up, if Tenzin turns up, my question is answered, right? My wish is fulfilled, because my very question is I want to see Tenzin or Tsering, one of them. So if one of them turns in, my question is answered. So through this, you'll be able to understand the logical operators better. And means, if I say this, I want to see Tenzin and Tsering. If Tenzin turns up, should I feel okay? Should I feel fine? No, I have to see Tsering as well, right? So when I say Tenzin and Tsering, unless both turns in, I should not feel okay, or I should not feel fine, right? So likewise, or is an operator, which will be in between the relational expression. Okay, don't worry, I'll come with the example. So if one of the conditions, if one of the conditions of the two expressions is true, the overall result will be true. Okay, however, in AND what happens is, unless both expressions are true, the overall answers, the overall result will not be true. Okay, so this is the thing that you have to understand about OR and AND. So for the overall result to be true, if one of the conditions is true, the overall result will be true in OR operation. In AND operation, all the operations need to be true for the overall result to be true. And then you have the NOT operator. NOT operator will reverse the truth value of a given operand. Now let's get on with the operation of the logical operator, right? So these operators could be performed on two kinds of expression or two aspects, right? The first one could be expression, okay, and the second one will be operand. Okay, so these operators could be either applied on expression or they could be applied on operand. Now let's check the first one. Let's say I have 3 greater than 2. Okay, 3 greater than 2, and then I use the OR operator, and then I have, let's say, 4 greater than 5, right? So look at the first relational expression. You have 3 greater than 2. So this will always give us the Boolean value. Remember, the result of the relational expression will either be true or false. So when I have this 3 greater than 2, which means this will give me the answer of true. However, 4 greater than 5, this will be false. So the first condition is true, the second condition is false. So since you have OR operator, the overall result will be true. Just like I came up with the example, I want to see Tenzin or Tsering. If one turns in, if one responds, I should be happy, right? So likewise, in OR operator, if one of the conditions is true, the overall answer will be true, right? If both the conditions are true, what better, right? However, if both the conditions are false, let's say 2 less than 3 is false, and then I use the OR operator, and then let's say 8 less than 7. Okay, well, this is true, right? So I'll just change this to 1. So if both the conditions are false, then OR will return the value of false. So this is simple, right? So this is the first way by which the OR operator could be applied to the expression. Okay, so these two are relational expression. Why relational expression? Because you have the relational operator in between. Now the next step is how and what happens if the OR operator is applied on operands. In the Python programming language, like many other languages, the Python interpreter will assign a truth value. Okay, it's a little complicated, but if you pay closer attention, it should be a cakewalk. The Python interpreter will assign or associate a truthful value to every kind of object. When I say kind of object, it could be integer, it could be float, it could be complex number, it could be string, it could be list, tuple, dictionary, sets. Likewise, I could just go on. So Python interpreter will assign a truth value to every kind of object. Those two truths value are again true or false. Now don't be confused between the true, false as a value with the Boolean values of true and false, which are the result of the relational expression. Alright, so you have two kinds of true false. The first one, which is the truthful or truthness, okay, or truthful values. There are two possible values, true, false, and then there is another pair which belongs to the Boolean values of true and false, which are the results of the evaluation of the relational expression. Now let's say if I come up with something like this, I think it's better to write here, say truthfulness, or the truthness value could be represented as small t. Okay, so the Boolean values true, false, starts with uppercase. Remember, you have big T and then you have big F. So as a mean of providing some differentiation, true, which starts from small t, means it's a truthfulness value of a given object. And then let's say if I have this false, which starts with a small f, this will again be a value of a given object. Okay. However, you have this true and then you have this false. Now these two are the Boolean values, which will be the result of an expression. These are the values of the object. I'll come up with some examples. Now let's say in integer 0 will have the truthness value of false. Okay, and then 0.0 will have the truthfulness value of false, and then 0.0j is again a complex number, so that will again have the truthfulness value of false. In the string, you have empty string, right? You have this, okay? This is a string, but this is an empty string. So what is the truthfulness value of this? So again, it is false. So likewise, for example, if I have this, so this is a list, remember? But this is an empty list. This is, nothing but an object. But what is the truthfulness value of this? Again, it is false. So I am checking the zeroness or the emptiness of a value. This value could belong to any type. This value could be an integer, this value could be a float, this could be a list, tuple, dictionary. So if it's empty, if there is nothing in it, then it will have the truthfulness value of false. If there is some value, the fact that it has a value, it will have the truthfulness value of true. Okay, so if I just cut the whole story short, true and false, which starts with small t, which again starts with the small f, they are normally being referred to the truthfulness of a given object. If the object has a value, be it any value, it will have true value. If it doesn't have anything, if it's empty, if there is nothing in it, if it's an integer, 0, if it's float, 0.0, string, empty string, so those are referred to as false. So I hope you are able to differentiate between the two. Now coming back to the operation, now let's say I have something like this, 0 or 0, okay? I have the first operand and then I have the second operand. Now let's say, as a general means, I think it's better to write something like this. Now this time, this A is not an expression, this B is not an expression, which means I'm applying this OR operator to the operand. Operand means the subject of operation. So what happens? Now the rule is, I'll be giving you the notes, don't worry. As of now, just try to understand. If the first operand has a false value, okay? If the first operand has a false value, the result of this OR operation will be the second operand. I hope you understood this. If the value of A, now this is just the general format. When OR is applied to operand, what happens? If the first operand has a false value, okay, the second operand will be the result of the entire operation. Okay, just get this. Now let's say the value of A. Let's say I have 1 and then 1 second. Okay, now let's say I have 1 or 0. Okay, so like I said, if the first operand has a false value, the second operand will be the result. However, if the first operand has a value of true, then the first operand will be the result. It sounds a little complicated, but it should be very easy. So let's say when I press enter, I get the result as 1. Now let's say if I have something like this, 0 or 1. If the first operand has a false value, the second operand will be the result. So when you press enter, I'll get the answer as 1. Now let's try some more. Let's say I have 0.0, right? So as the rule, if the first operand has a true value, then the first operand will be the result. If it has a false value, the second operand will be the result. So since the first operand has a value of true, now when I say true, I'm not referring to the Boolean values, I'm referring to the truthfulness value, right? So when I press enter, what will be the answer? The answer will be the 5. Okay, so likewise, I could just try some more. Let's say I have something like this. Okay, so look at the first operand. Remember, so this operand has a false value. False value in which kind of object? In what kind of object? It's a string object, right? So when you look at this, this string has a false value. If it has a false value, the second operand will be the result. Okay, so we'll check one more. Okay, so any answers in your mind? So this, since the first operand has a truthfulness value of true, the answer will be the number itself. So it will be the A. Okay, so you need to remember this. If the first operand has a false value, the second operand will be the result. If the first operand has a true value, the first operand will be the result of the logical operation, right? So now let's say we have a situation. Say 20 greater than 10 and then OR A plus 1 greater than 0. So again, this is an expression. So in OR operator, what happens is, if the first one is true, remember, if the first one is true, it will just pick up the value of the first operand as the result, which means it will not bother to check the second operand or the second expression. So this is what happens in OR operation. It's obvious from the very definition. If the first operand is true, then let's say Tenzin is sitting. If Tenzin turns in, should I be checking whether Tsering will follow the suit? No. I'll not bother. Even if it turns in, even if he doesn't turn up, I don't need to check the second boy, right? So likewise, the proof is, so when I press enter, look at this, I get the answer as true. But actually, if you take a closer look, this expression should evaluate to false. Let's say if I just retype this, 1 greater than 0, and then when I press enter, I get to see the error, okay? But when I run the statement, I get the correct result of true. The reason is, in OR operation, if the first condition is true, then the overall result should be true. I don't need to check the second statement. So that's what Python does. Python interpreter will not bother to look at the second the statement. Okay? If it does check the expression, it should evaluate to the error. It should report an error, but it doesn't. So it clearly tells us that if the first operation in the OR operator is true, the answer will be true. The Python interpreter will not check out the second operand or the second expression, and it did not, because it got the result from the first operand being true, right? So once you understand this, it should be pretty much the same for the AND operator, okay? So in AND operator, what happens is, let's say I have 3 greater than 2, and then you have AND, say 4 greater than 3. So when you press enter, I get the answer as true. So this is the only combination which will give us the Boolean value of true. All the conditions need to be true. If I say I want to see A and B and C, which means if just 1 turns up, if 2 turns up, that should not be enough. I should see all 3 students. Hence, I have this AND sandwiched, between these 3 students, right? So let's try out this 3 greater than 2, and then 4 greater than 3. This is true, but this is false, right? Okay, sorry, both are true. I'm sorry. So let's 3 greater than 2, and then let's come up with 3 greater than 2 and 5 greater than 6. Now this is true. Okay, this is false. Am I right? Okay. So I get the answer as false. If both the conditions are false, it has to be false. So again, this is how the AND operator is applied onto the expression. Now let's do the second part. How AND operator is applied to the operand. So again, let's come up with the general, the syntax. So when I have something like this, A and B, now this time it's just the opposite. Remember in OR operator, if the first operand has a false value, the second operand will be the result. So just vice versa. If the first operand has a false value, the first operand will be the result of the expression. Okay? So this is how you should learn. So if the first operand has a false value, the first operand will be the result. If it has a value of true, then the second operand will be the result of the expression, right? So once you get the first one right for the OR operation, the AND operation is basically, the opposite definition for the AND operator. Now let's say I come up with examples like 0 or oops. Okay, let's say I come up with example like 0 and 0, right? So look at the first one. Say in order to come up with slightly better example. Now, will I get the answer as 0 or 0.0? Okay, so like I said, if the first operand has a false value, the first operand will be the result. Okay, so which means I should get the answer as 0. So let's say if I have something like this, 0.0 and 0. If the first operand has a false value, the first operand will be the result in the AND operation. So this time will I get 0 or 0.0? I'll get 0.0. Okay, so let's try some more example. Say, okay, so look at the first operand and look at the second operand. Both are string. Both are again just another kind of object. So in the first operand, what do you have? You have A, which means it's not empty. If it's not empty, then it will have the truthfulness value of true. Okay, so this will have true. If it has a true value, then what happens? The second operand will be the result, right? So this is how I get this. Okay. However, if I just turn the table and then if I have something like this, if the first operand, now this is an empty string, it doesn't have a value, so which means it will have the truthfulness value of false. So false and true. False and true means if the first operand has a false value, the first operand will be the result, right? So that's how I get this. Please take note of this. There is no space here. If it has a space, then the truthfulness value will not be false. Rather, it will be true. Even though it's not visible to our eyes, space is as important a character as the rest of the characters. Right? So I hope you're clear with this. Okay, I don't need any more example. Right? So these are how you could actually use the logical operators either on expression or on the AND operator. Now let's check out the not. Not operator will just reverse or negate the truthfulness value, right? Let's say if I have something like this, not of A. Okay, so when I press enter, what answer should I get? I'll get the answer as false. So the logical operator like the OR and the NOT, they will always come out with the Boolean values of either true and false. Okay, now look at this. How you actually check is, look at this particular literal. This literal is a string literal, right? So forget this for a while, just focus on this. This is a literal, this is nothing but an object. Can you just tell me the truthfulness value of this? Is it this, or this? It has to be this. Okay, you are checking the emptiness or the zeroness of the object. So since it's not empty, it will have the value of true. So not of true means you will get the answer as false. Just the opposite. Okay, so likewise, if I have something like this, not of 0.0, what answer will I get? I should get the answer as true. And then likewise, if I check 1.0, 1.1, now I'll get the answer as false. Okay, so maybe one more example. Say if I try this, let's check. Good. So this is an empty list. Empty list. Remember, the list is enclosed to the pair of the square bracket, right? So when you run this, not of this, you will get the answer as true. And then let's check one more. 0 plus 0j. Okay. Sorry, this is not a complex number, right? Okay. So when you press enter, I'll get the answer as true. So this is again a complex number which will have the false as the truthfulness value, right? So this is a very, very important concept, right? Okay, I'll just end the first part and then I'll continue with the second part.